and a non-ideal solution. Ideal and non-ideal solution. Okay. The first one is ideal solution. Ideal solution, the solution which obeys Raoult's law over entire range of concentration is called ideal solution. What is Raoult's law? As I told before, Raoult's law means it is the solution of two volatile components where the partial vapor pressure of each component is directly proportional to its mole fraction in solution, for which the mathematical expression was P total is P1 naught J1 plus P2 naught J2. Okay, this is the mathematical expression of Raoult's law. The solution which obeys this equation over the entire range of a concentration is called ideal solution. Okay, so in ideal solution, what are the conditions? That is, what are the conditions of a solution to be ideal? That is to be followed to the Raoult's law. So the solution where the force of attraction between the solute and solvent is same with the solute-solute or solvent-solvent interaction is said to be ideal solution. Okay, so the solution is ideal one if the solute-solvent interaction is same with that of solute-solute or solvent-solvent interaction. Okay, this is one of the criteria for a solution to be ideal. In here, for solute we take suppose A, for solvent we take suppose B. So AB interaction means it is solute-solvent interaction. So the solute-solvent interaction must be same with that of solute-solute or solvent-solvent interaction. Okay, next one is during the preparation of the ideal solution there is no volume change. That is delta V change in volume during the during the mixing process of the two components, that is solute and solvent, should be zero. Change in volume should be zero during the preparation of the standard solution. Where this criteria is satisfied, then the solution is said to be ideal one. Third one, delta H mixing must be zero. That is, there is no heat energy released or absorbed during the preparation of the ideal solution. So what are the criteria or conditions for a solution to be ideal? So for ideal solution, the total vapor pressure must be equal to P1 naught J1 plus P2 naught J2. This is the definition, that is the solution for which the total vapor pressure is the sum of the partial vapor pressure of the individual components is said to be ideal solution. This is Raoult's law. The solution which obeys this Raoult's law, that is this mathematical expression, is said to be ideal. For that, these three criteria must be satisfied. So for ideal solution, the solute-solvent interaction must be same with that of solute-solute or solvent-solvent interaction. The change in volume must be zero and the change in enthalpy must be zero. So these are the criteria for a solution to be ideal. Next, what are the suitable examples for a solution to be ideal? Strictly speaking, there is no solution there is no ideal solutions. There is no solution which is ideal at every range of concentration, like that of ideal gas and real gas. If you in states of matter, there is no gas which is ideal at all condition of pressure and temperature, but only at a definite condition, that is at high temperature and low pressure, there are some gases which tends towards ideal. Similarly, there is no ideal solution, but at a particular condition, that is in very dilute condition, there are some solutions which tends towards ideal. Okay, so those solutions which tends towards ideal at a particular condition, that is at a very dilute condition, those examples are benzene, toluene, you know, C6H5CH3, okay, N-hexane, N-heptane, N-heptane, ethyl chloride, ethyl bromide. These are some solutions which tends towards ideal at a particular condition. What is the condition? At very dilute condition, these solutions tends towards ideal, or these solutions behave as ideal at a particular condition, that is at very dilute condition. Okay. Next, second part is non-ideal solution. Non-ideal solution. The definition is simpler. The solution which does not obey Raoult's law, all range of concentration is called a non-ideal solution. So, what is Raoult's law? That equation P total equal to P1 naught xi1 plus P2 naught xi2. If this equation is not satisfied by the solution, then the solution is said to be non-ideal solution. So for non-ideal solution, the total vapor pressure is not equal to P1 naught xi1 plus P2 naught xi2. If the total vapor pressure is not equal to that of the sum of the partial vapor pressure of the individual components, then two conditions arise. That is, either total vapor pressure is greater than P1 naught xi1 plus P2 naught xi2. This is one condition. Another condition, P total is less than P1 naught xi1 plus P2 naught xi2. These two conditions arises. If P total is not equal to P1 naught xi1 plus P2 naught xi2, then either this one satisfied or this one satisfied. Okay, and from this, the solution is called non-ideal solution showing positive deviation. So non-ideal solution is of two types: non-ideal solution showing positive deviation, non-ideal solution showing negative deviation. So which non-ideal solution shows positive deviation? The solution where the total vapor pressure is greater than that expected in Raoult's law is said to be non-ideal solution showing positive deviation. Similarly, what are the non-ideal solutions showing negative deviation? The non-ideal solution where the total vapor pressure is less than that expected in Raoult's law is called non-ideal solution showing negative deviation. What is the expectation in Raoult's law? In Raoult's law, the expectation was total vapor pressure must be equal to the value of P1 naught xi1 plus P2 naught xi2. So consider the first case, that is positive deviation. So in positive deviation, what is the first condition? For positive deviation, this is the definition: the total vapor pressure must be greater than P1 plus P2. Okay, or P total is greater than P1 naught xi1 plus P2 naught xi2. This is the first condition. This is the definition. Which solutions behave as non-positive deviation in non-ideal solution? The solution where the total vapor pressure is greater than the sum of the individual partial pressures of the components is said to be the non-ideal solution showing positive deviation. Okay, and as here the total vapor pressure is more, so in which condition the total vapor pressure increases? The total vapor pressure increases when the force of attraction decreases. So here the AB interaction is less than AA or BB interaction. As the total vapor pressure is more, so the solid solvent interaction must be less, and when a solid solvent interaction is less, then during the preparation of that solution, delta V is positive and delta H is also positive. So what is the meaning for delta V positive? Delta V positive means the volume of the solution is greater than the sum of the volume of the solute and solvent. As the volume increases, so change in volume positive. As the energy is absorbed during the preparation of the solution, so the process is endothermic, so delta H is positive. As the process is endothermic, during the preparation of the solution, energy is absorbed. So these are the four conditions for a solution to be positive deviation of non-ideal solution condition. So in negative deviation, just opposite. In negative deviation, the total vapor pressure is less than P1 plus P2. The AB interaction is greater than AA or BB interaction. Delta V should be negative. delta H should be negative. So these are the comparison between the positive deviation and negative deviation. Next, what are the important examples of a solutions in positive deviation and negative deviation? So in positive deviation, the important examples are ethanol and water. Ethanol and water is an important example of positive deviation. Why ethanol and water shows positive deviation? Because the force of attraction between ethanol and water is less than the force of attraction exists within the water molecules. Similarly, there is other examples like acetone, carbon disulfide CH2, acetone, benzene, acetone, ethanol. Okay, so these are the four examples of positive deviation where the solute-solvent interaction is less than that of solute-solute or solvent-solvent interaction, and as the solute-solvent interaction is less, the total vapor pressure of the solution is more than expected in Raoult's law. Okay, next one is solutions showing negative deviation. The negative deviation, what are the important examples? Important example is acetone, chloroform. Acetone, chloroform. Acetone and chloroform is an important example of the non-ideal solution showing negative deviation. So in negative deviation, the force of attraction between solute and solvent is more. So why the force of attraction between acetone and chloroform is more? Because in between acetone and chloroform there exists intermolecular hydrogen bonding. So there exists intermolecular hydrogen bonding between the acetone and a chloroform molecule, because this hydrogen atom is electron deficient as it is attached to the carbon to which three powerful electronegative chlorine atoms are attached, by which the hydrogen atom becomes electron deficient and oxygen is electron rich. So there exists hydrogen bonding. As there exists hydrogen bonding between acetone and chloroform, so the AP interaction is stronger than AA or BP interaction, and as the AP interaction is stronger, so the total vapor pressure is less, by which it shows negative deviation. Other important examples: phenol and aniline, phenol, aniline, and all mineral acids with water, that is HCl with water, sulfuric acid with water, nitric acid with water, all of them shows negative deviation. Any mineral acids on dilution process, energy is released because they have strong affinity towards water, and as energy is released, so delta H is negative. When delta H is negative, then the solution shows negative deviation. So this is all about your ideal solution and non-ideal solution. So ideal solution means the solution obeys Raoult's law over entire range of concentration. Strictly speaking, there is no example of ideal solution, but there are some solutions which tends towards ideal behavior only at a very dilute condition. Non-ideal solution is of two types: positive deviation, negative deviation. Okay, another part is there.